Welcome back to my new video. So, last time we saw many things about TypeScript, and we stopped where we talked about type aliases. Let's keep going along the same route, and let's start by talking about literal types. Let's have a look at what is a literal type, when it's useful, and then we're gonna proceed in the second part of our tutorial. I hope you guys enjoy, and let's get started. Let's start by defining a variable. So we use the keyword let, because we're gonna actually modify a string, and this string is of type string, as we saw already. So let's give it a name, a string with a value an example string. Now, of course, this is of type string, so any string can be assigned to this a string variable. We can reassign the variable, and we can say change to the string. So if you're gonna console.log these two values set to different points in terms of the program, we're going to get a string to have, of course, two different values. And this is, of course, obvious, so why should you care about this? Well, you should care about this because you know that a variable is a variable if it changes. So if you actually open the console, we can actually see that this variable has changed, as you might know from, elementary school programming. However, in some scenarios, a variable, although in programming you call everything a variable, is actually a constant, is something that doesn't actually change. So if I make a constant something with a particular value, so non-changing string, and I say I don't change, TypeScript infer the type I don't change. It's not a type string, it's still a string, so all the methods of a string. However, the type is exactly I don't change. So if I instead specify is a string, now TypeScript is going to say, well, this is a string, is a generic string type, not of type I don't change. A literal type in TypeScript is when I define a variable to have a literal type. So the value of this variable is exactly I don't change. In which scenarios this is actually useful? This is actually useful in every scenario in which the value of a constant or the value of a string or the value that a variable, a property of an object can get is within a defined range. So for example, let's imagine the placement of an object, of a div, of an element in the DOM to have top, bottom, right and left. So let's write a placement option, and using the types we learned in the previous lesson, this variable can actually have exactly the values of left, right, top and bottom. And in this case, we're gonna assign to this placement variable the type, let's say left. Let's define the placement type to be exactly equal to left, right, top and bottom, because as you saw in the previous lesson, you can actually have variables named this way. And let's say now we can define a function that accepts two parameters. One is a div, so let's give it an object of type HTML div element. There you go. And then a variable placement of type exactly placement. What now TypeScript is going to be able to do? We can assign the style property of this object, which will contain top, right, left and bottom, as you can see from the autocomplete. The value of the placement variable passed through this function, and we can say, well, set it wherever it's passed through, you pass it to 0 pixels. Maybe the object is, position absolute, and then you pass the placement. This function is going to say, well, this object is going to have a style of 0 pixels. Now imagine that we give a variable that does not exist in the style element. As you can see, array TypeScript is complaining underlining placement in red with an invalid, because we use an invalid style, and is saying that the element, the index expression that we are using, it essentially does not exist in the style defined in the CSS style object. While if we remove this invalid style, you can see that TypeScript is not complaining anymore, and we can even add new variable, new properties, such as margin property, because the margin on the style is actually a valid value. As you can see, TypeScript is not complaining. Here I forgot to add the function name, of course, that's why there is also this other complaint from TypeScript. Let's now keep talking about the same topic, but now we're going to talk about literal inference. So let's say we have an object now, and we define an object with a property, for example, some property which is equal to a string, maybe ABC. what's going to happen? Although we defined it as a constant, the property is just a string, because in JavaScript, when you have a constant object, and the properties of the object can actually be modified. So I can actually do object dot property equal to a different string. Nothing's gonna happen. What if we want to have a literal type to be used inside an object instead? What we can do is to simply say, well, we can add the as keyword and then say as ABC, and now as you can see the property ABC became simply can only be called ABC. Let's do a second example. If an object variable has a property called ABC, now we can go ahead and say that object variable dot property is equal to a different string, no complaint from TypeScript. So we can assign, for example, a different string. It's gonna work just fine. However, if we try the same for obj dot property and we assign anything different from ABC, for example 111 or anything, TypeScript is going to complain, but not for ABC. ABC is the only assignable type to ABC. Alright, it's a string, but it's a constant string, it can only be of one value. If you're wondering about the usefulness, think about when you have properties in methods, placement variables, and anything that can only accept not any string, but a particular subset of strings. Okay, let's follow another example. Let's keep going. Let's imagine that we have an object that has many properties that you want to fix in this object. So we have one property which is a string, another property which is a number, another property which is a boolean. We want to fix these three properties as ABC, as a number, and as a boolean with properties ABC, 1 and true. So what we use? We're gonna use the keyword as const. So it's gonna take all the variables inside this object and treat them as a read-only variable. So in this case, prop 1 can only be ABC, prop 2 can only be 1, and prop 3 can only be true. And this is exactly the equivalent of going through each properties and say as ABC, for the second property as 1, and as true for prop 3. Missing a comma just above. Let's fix it. As you can see, it works exactly the same. However, if you want to do a shortcut, you take the object and you call it as const, and this way you're gonna get all the properties in the object as a literal type. Let's have a look at the next bit. We're gonna talk about enums. So, what is an enum? An enum is something similar to what we had before. Do you remember when we did positions and we said that position can be left, right, top, bottom, etc. An enum is a similar concept that doesn't actually exist in native JavaScript, but that TypeScript makes available to us. It allows us to define variables with a proper name. For example, sometimes we have things which are defined with the 0, 1, 2, 3, and they have corresponding types such as roles. While if we are gonna use an enum, we can actually use the literal name, which makes reading our code much easier. So let's make an example where we have an enum with roles. So we can have an admin, which is gonna be equal to 0, super admin, which is gonna be equal to 1, user 2, subscriber 3. And editor is gonna be of value 4. So now in TypeScript we can actually be able to access roles.admin inside our code, and is going to compile to a JavaScript value of 0, making everything much easier to read compared to if we actually used a different type of value. We could have done, of course, in classic JavaScript, const roles admin equals 0, const roles superadmin 1, etc. However, this way it's much easier, and we can actually define, in this case, for example, a function checkRole that takes a user, and the user object as a role of type roles, and we can check if the role is, for example, an admin. And if you do checkRole of an object role, which is 1, it actually works perfectly fine. This will return that the role is actually a super admin. Let's have a look at what the build is equivalent to. Basically do roles.superadmin will be the exact same value. Let's have a look at the build object. As you can see, TypeScript is going to do all of this, where the value is going to be 0, 1, 2, 3, and 4, and it's going to be of a value of a numeric value, which is going to be way easier to read in our code. Let's have a look at different types of enums. For example, now we saw numerical enums with an automatic indexing, so 0, 1, 2, 3, 4. But they can also have values such as strings. So following our example from before, we can have an enum position with a top, bottom, left and right, with the literal values of top, bottom, left and right. It actually takes an equal sign, not a colon type. So it's bottom equal, let's change this. Okay, so now we have the right values, and we can check for position dot bottom is going to return bottom with upper lowercase bottom, etc. We can have mixed enums. Doesn't have to be of one type, can be simply an indexed one, a literal one, or even computed ones if you wanted to, such as the result of a function. And then you can just access them normally as you would. A mixed.admin will have a value of 0, mixed.editor will be the value of editor. Let's just console log, just for curiosity, these two variables, so mixed.admin and mixed.editor, to see what the actual type is it. Let's open the browser, and you can see that the values are exactly 0 and editor.